Okay, so now we will discuss how to try our program on a simulator. So we look for the 8085 simulator. I open it. Okay, the program is discussed in the class on how to multiply two numbers using the DAD instruction. Okay, so when two numbers here are multiplied, we get a 16-bit answer. So we will multiply a big number with a small number so that we see a 16-bit answer. Now if you go through the program that we have discussed in class, the memory locations that hold the data are C000 and C001. So I have decided to multiply FF with 3. So in C000 I have put FF, and in C001 I have put 3. These values could change. When you're executing the program for the examiner, she will ask you to change these data values and re-execute your code and show her the answers at C002 and C003. Now if you see, our program starts from C006. We have kept two memory locations after the data memory locations blank. So we start with our program. Okay, so in C000, okay, I first press and enter my data FF. This is one number to be multiplied. See what I've done at the start. When I open the simulator, I click in the memory area and I type the first address C000. Then I click in the data area and I type FF. Subsequently, I just press next and go to the next memory location. Okay, in C001, the number that I want to multiply FF with. So I'll multiply it by 3. Okay, the next two memory locations will hold my answer. So I initialize it to 0. You don't even have to initialize it to 0, but as good practice, I initialize the two memory locations C002 and C003 that will hold the lower byte of my product and the higher byte of my product to 00H. Now you go next. This memory location will be unused. Okay, if you want, you set it to 00. Next, this also I keep unused, and I start my program code after keeping two memory locations blank as good program practice. Okay, so from C006 I have my code that starts. So in 6006 I store the LXI H hex code, which is 21. Click on next. In 007 I initialize my HL register pair to 0000. Hence I store 0000 in C007 and C008. Then comes C009. The instruction is MDI. Okay, the hex code for MDI D is 16, so I enter 16. Go next. Okay, in C00A I initialize D with 00H. Okay, now in C00B is my LDA instruction, so it's 3A followed by the memory location, the lower byte. In this case it is 00. Next, the higher byte, it is C0. Go next again. In C00E it is the move E comma A. Since my DAD instruction will be using the DE register pair, I am initializing my E register with one number that will be used in the multiplication or obtaining of the product. So in C00E, okay, the instruction move E comma A, which is 5F. Look into your program sheets, please, all of you, as we do this. In C00F, we store the LDA again, 3A. Next, in C010, the lower byte of the address followed by the higher byte of the address. Okay, you can click on the previous and the next. If you feel you have done something wrong, you could reconfirm the data in the memory locations by hitting the previous button and going next and completing the program. Now in C012 is the DAD instruction, DAD D, which is 19. Okay, the hex code. C013, it is the DCRA 3D. Okay, so in this program we are using the A register as the counter, hence DCRA. C014, okay, jump not 0 hex code C2. Then we have the next memory location C015, the lower byte of the address. C012, in C016 we store the higher byte of the address. Okay. Now in C017 is the SHLD instruction. Now the HL register pair has the product. So I need to store the lower byte at C002 and the higher byte at C003. Hence in C016 memory location 16, okay, in C017 memory location I store SHLD code, that is 22. Next, the lower byte of the address 02. Next, the higher byte of the address C0. Next, now in C01A is the end of my program hex code, halt 76. Now confirm this whether you have done it right. I'll say okay, C01A 76. Now just confirm, browse through your program, make sure that every memory location has the right code of your program. So I'm just clicking on previous to confirm this, to confirm that I have made no errors. Okay, then previous in C015 is 12. Okay, C014 is C2. Previous C0, okay. Then C012 is 19, that is the DAD instruction. Okay, just confirming it so that I get no errors and I get the right answer, what is expected. Okay, C00B has 3A, correct. A has C00A has 00, C009 has 16. Okay, I'm almost reaching the beginning of my program, and C006 has 21. Perfect. Okay, now what I'll do is I'm ready to execute this program. So on this simulator I will hit the reset button. You can come to the end of the program if you want. My program ends by, I just click on next, and I come to the end of the program. My end of my program is at C01A, so I go next. Okay, one beyond that, and I click on reset, go, and now which is the address of my memory of my program. The data is C000, C001, C002, C003. After that we have left two blank and my program starts at C006. That's it. After that, hit the execute button. Okay, now you have got your answer. To verify it, okay, now we will do two things. I need snapshots of the 4 memory locations, in this case C000 to C003, and I need the status flag and the register content. Now if you send me a snapshot of this, it's fine, I can see the status flag. Okay, from here I can see that okay, the program counter ends at C01A. Okay, the stack pointer is FFFF. HL register pair has a value, BC register pair has something, D register pair. So send me the snapshot. Okay, you could have done so by clicking on examine register, but it's given it to me after executing the program. Now click on examine memory. Okay, now see here, click on the memory. It's C01A. So click there or press your finger there and go to the memory location of the data. Where is the data? C000. Okay, this is the value FF. Okay, take snapshot to send to me. Next, take this snapshot. FF has to be multiplied by 3. Take the second snapshot of the C001 memory location. Next, answer is FD. This is what I want. Next, the okay, the higher byte, that is the carry that was generated after the multiplication, C003 is 02. Take snapshot of this memory location. So 4 snapshots of the 4 memory locations showing me the data, that is the two numbers to be multiplied, and the answer that's obtained after executing the program. Okay, and the status flag. Click on examine register, send me the snapshot. Now the other thing is, for every program we are having a case 1 and a case 2. I want you to execute this program for two sets of data. So in this case, the second set of data is of your choice. So let me do in the second execution of the program, I will multiply FF by 4 and I'll see what answer I get. So done. After you have done this much snapshot, okay, go back to examine memory, come to C000, okay, the data is FF, let it be the same. I will multiply FF with 04 this time. 04. Next, okay, I'll set this to blank, I'll set this to blank, and my program remains the same. So I scroll down to the program till I reach the end. Okay, okay, what's C0 till C01A. So still C01A, I keep clicking next, next, next. Make sure there's been no change here. Okay, so I come down till I come to 601A. Done. Reset. Go. Which is the starting address of your program. You have to execute the programs that starts from C006. Execute. Done. Send me the snapshot. Okay, this is for the case 2, the second set of data. Now the 4 memory locations, again I want the snapshot. So click on examine memory, then click on the memory area, type C000, click on next, it is FF, click on next, it is 04. So FF is multiplied by 4 this time. So go to previous, click a snapshot. Go to next here, click the snapshot. What should be the answer? The answer should be FC this time, because FF is multiplied by 4 this time to give FC, and now the carry has increased to 03. So this is what I want for snapshot and status register. So examine memory and examine register is what is required to send the required data to me. And when will you do it? When you execute the program. Reset, go, okay, type the memory location of the starting memory location of the program C006, hit the execute button, and then look for the proper memory locations to send me snapshots and the status register. I hope you have understood. The same applies for every program that you type on the mobile simulator. Bye.